So this section is talking about some different types of chemical reactions. So one of them has been given, so acid plus base gives neutralization. Okay, and it wants you to complete the other two. So we've got alkenes being produced by heating alkanes with a catalyst. Okay, so if we take long chain alkanes and we heat them with a catalyst, they hopefully break down into smaller alkanes, and ethene gas is usually what comes off, ethene or propene. And we've tested this before, and it bubble it through water and with the ceramic catalyst, and hopefully we can decolorize some bromine water with it. Okay. The next one, you've got proteins breaking down into amino acids by heating with aqueous acid. So this is our condensation polymers. So when we looked at this, if you're putting the monomers together, that's polymerization. But the opposite of this is when we were trying to introduce the small molecules back into the polymer and putting it back into the monomers. So actually, you might have had it taught this way to start with, so sort of retrosynthesize it. So to take the big polymer and break it first, sometimes students find that a little easier. So if you're introducing water, yeah, this is hydro, isn't it? It's hydrolysis. So it's not always water, but it tends to be called that anyway. Okay, so hydrolysis is when you're taking the proteins, the polymers, and breaking them up. Yeah, protein is just a natural example of a polymer. We might have dealt with things like nylon or polyester, but it's the same process. Molecular formula of 4 organic compounds shown below. State and explain which of the compounds W to Z could be an amino acid. Well, straight away, only one of them contains the nitrogen available to form an NH2 group, okay, which is an amine group. So an amino acid must have an amine on it, but it must also have the carboxylic acid group, which would be something like this. And then you'd have the R group just represents something else, the rest of the molecule that we're not really interested in. Okay, so that would be our COOH group. State and explain which of the compounds W to Z are hydrocarbons. Okay, well, hydrocarbon is carbon and hydrogen only, which means then the top two get excluded, so it must be W and Z. Ethene is a colourless gas that reacts to form polyethene, which is a white solid. Describe what happens when ethene molecules react to form polyethene molecules. I'm not sure I like the form polyethene molecules. I suppose it is still technically a molecule, it's just a very, very long one. But anyway, we'll leave that for the moment. Draw a diagram to help you answer this question. Use the symbol E to show an ethene molecule. Personally, I think it would be easier if they just let us draw it properly. Give us, 2 carbons, double bonds on it, some hydrogens. Let us just do it right, rather than actually try to simplify it and put these little E's in there. I don't think that actually helps. But anyway, you can see up here, the little E's should join together to form a longer chain. Okay, so I've put 3 together there. So what actually happens in a real molecule? The double bond breaks. Okay, and rather than bonding to something else like an addition molecule, like the bromine, what it actually does is bonds to the next molecule. So they keep bonding to the neighboring molecule, making this longer and longer chain. Okay, so long chains of monomers that bond together is obviously called a polymer. Okay, state the full name of the type of chemical reaction that occurs. Well, it's obviously polymerization, and because that double bond is opening up, that's addition polymerization. 2 reactions of alkenes, ethene and propene, are combustion and polymerization. So describe one other chemical reaction of alkenes. So this is the other thing that you can do with an alkene, is that double bond. Rather than getting all the little double bonds to bond together to make the polymer, you could just get it to add to something else. And I think I mentioned bromine already, so we could put bromine across that double bond. So if you think about it, we've got a double bond like this with our 4 things around it. Okay, and if we decide to open up that double bond and put some extra bonds on there, then now I've got the chance. 2 hydrogens there, I've got now 2 spaces. So I can put what I like on there. I could put some bromine in there, I could put some chlorine, I can do it with water. If I put water on there, I'll put H on one side and OH on the other. That would actually turn it into an alcohol, because there'd be an OH group. Yeah, so hydrogen on its own, you could fill it in and make it saturated. That's called hydrogenation. So again, lots of possibilities, and in every case it's the double bond that's opening up. Okay, state one difference between addition polymerization and condensation polymerization. I have put sort of not the monomers in there because I must admit the question's perhaps a little vague. So again, I could quite easily expect someone to be talking about the fact that you've got different monomers. Yeah, so you've got monomers with double bonds for addition, whereas in the condensation polymers, you've got two different types of polymers. Yeah, so there's quite a big difference between the polymers, but they're not really looking for that, it would seem. So again, it's a little bit vague. If in doubt, as always, you write more than you need. Okay, so the big thing is with addition polymerization, you don't get any byproduct. Yeah, so no byproduct for the addition polymerization, this one here. In fact, what it means is it's got a very good efficiency because everything that you react actually becomes product. Whereas when you do condensation polymerization, the small molecules are actually released and they're actually not any use to you. Okay, it's actually called atom economy, and this might be something you do in the future. Okay, so small molecules are released, usually water, but sometimes hydrochloric acid. Okay, in fact, actually this example here would be HCl that would come off. So this is nylon. It's made from molecules A and B. Okay, this one shows an incomplete section. So what's going to happen is, as this comes together, yeah, we need to get HCl to come out. Okay, so what would happen is we'd form a new bond between the carbon and the nitrogen, but that carbon's now got too many, so that Cl would fall off and one of the hydrogens would fall off too, and that would give you HCl. So that'd be a little molecule coming off. Don't worry if you've got your C double bond O and NH on the different side. The point is that it can the single bonds, the horizontal one here, can rotate anyway, so it doesn't matter if it's up and down. Okay, and that's the last one.